Okay, now we've got one more special case. When you've got a trinomial, and if you notice that the first term and the last term are perfect squares, it may factor to a binomial squared. All right, so, and I'll show you how to check if you did it correctly. So you take the square root of that first term, so 2k. You take the square root of the last term, which is 1, and you always take the first operator, squared. And this is how you know if you're correct, because sometimes they'll throw one in that are not. If you multiply 2 times these two terms, so 2k times 1, 2k times 1 is 2k, 2k times 2 is 4k. If when you do that, it ends up equaling that term, you know that indeed this was a perfect square trinomial that can be factored. So again, let's recap. You take the square root and the square root of the first and third term. You take that operator, square it. And how you double check is you multiply those two times 2. And if this term right here is this term, then you know that this is correct. All right, now look at here. 75 is not a perfect square. 27 is not a perfect square. But 75, 90, and 27 all have a 3 in common. How I know that? 7 plus 5 is 12. 3 goes into 12. 9 plus 0 is 9. 3 goes into 9. 2 plus 7 is 9. I know a 3 can be factored out of that. 75 divided 3 is 25, so 25m squared. 90 divided 3 leaves positive 30m. 27 divided 3, and now look at what we have. 25m squared is a perfect square, and 9 is a perfect square. So take the square root of 25m squared, 5m, take this operator, square root of 9, square it. Now this is a little bit tricky because there's this 3 involved, but how you know you did it correctly, we're looking for this one now. Instead of that original 90, we're looking for 2 times this should equal 30m. So 5m times 3 is 15m. 2 times 15m is 30m. So that indeed was a perfect square. All right, that's it for this one.